Hey students, welcome back to my YouTube channel. And we were discussing about the basic topic from stereochemistry. And in this lecture, I would like to discuss with you what is meant by racemisation and resolution, and what is relative and absolute configuration, that is DL notation. And Racemisation means the process in which one enantiomer, that is a dextro or levo enantiomer of an optically active compound, is converted into a racemic mixture, that is a mixture of D and L in equimolar mixture of D and L, that is dextro or levo rotatory enantiomer, is called racemisation. And it is carried out either by action of heat or light or chemical reagent. For example, here I have shown the dextrorotatory lactic acid, that is D or plus, that is usually shown in small letter D. This means that this is dextrorotatory, and it in the presence of base it undergo tautomerism, that is this hydrogen get abstracted and it tautomerize, that is it become enolized, then this hydrogen goes to this oxygen atom and it form an enol form, and this enol form is usually unstable, and this enol form can yield a mixture of dextrorotatory lactic acid, that is hydroxyl group on the left, and levorotatory lactic acid. Here you can see that OH group is on the right, and if this yield an equimolar mixture, that is 50% D lactic acid and 50% L lactic acid, that is called racemic mixture, and that this process is called racemisation. Okay, and what is meant by resolution of racemic mixture? Resolution of racemic mixture means the separation of a racemic mixture into its D and L enantiomers are called resolution. Since enantiomers have identical chemical or physical properties, and D and L have same physical and chemical properties, their separation is not possible by ordinary methods such as fractional distillation or fractional crystallization, etc. So there are many methods, which is going to be discussed now. The first method, this is by Louis Pasteur. In 1848 he has put forward, that is the mechanical separation. So what is meant by mechanical separation? So you have a mixture of D and L form. You want to separate D and L. So if there is any well-defined crystals having different shapes, which are mirror images, what you can do is you can carefully separate the crystal of the plus and minus form, that is D and L form, in racemic mixture by hand picking. So this will be having different shape with the minus form. D will be different from minus form, the shape. That means structure is same, but the orientation will be different. So you have to identify these two forms by magnifying glass and small forceps, and you have to hand pick it. So you can understand that this is very difficult job. So you have to hand pick different crystals of T and L form, but this was done by Louis Pasteur in 1848. He separated crystal of racemic sodium ammonium tartrate into D and L form, and this is very laborious, very difficult. It has only historical importance. That is first time he has separated the two enantiomers. So far no one has made it. And the second method from the same person in 1858, that is biochemical separation. So what is biochemical separation? You can separate T and L form by selective destruction of the one through biochemical process. So some microorganisms such as yeast or moths or bacteria allowed to grow in a solution of racemic mixture. what they do is they selectively assimilate one, leaving one enantiomer. So one enantiomer will be killed and other will leave. For example, D-L-tartaric acid with mode penicillium glaucum, D form is destroyed and it leaves L form. But this has some disadvantages. One is half of enantiomer is sacrificed. And second one, finding suitable organism to do this function is difficult. Third one, in some case enantiomer is poisonous. It will to the microorganism which cannot be separated now. So we have another method, that is third method, chemical method from Pasteur. Has done it in 1858. What he did is he converted a racemic mixture of enantiomer into diastereomeric derivative, that is DL-lactic acid. He treated with a pure enantiomer L-brucine. What he did is he obtained a diastereomer of D-L-brucine, that is D-lactate, and L-brucine, L-brucine, and L-lactate. That is, it is a diastereomer and it is a diastereomeric salt. Enantiomers are having same properties, but diastereomer is having different properties. So this can be fractionally crystallized and due to different properties. And this you get separated, then L-lactic acid, L-brucine, and D-lactic acid and L-brucine can be fractionally crystallized. Then finally it acidify on acidification or basification you get the pure enantiomer. This is the chemical method and this is the most common method too. And the fourth method is selective adsorption method. That is, a solution of racemic mixture is passed through a chromatographic column of finely divided optically active adsorbents such as starch and cellulose. This is column chromatography, but the one issue is that you have to use very costly column, that is optically active column compound with a adsorbent you have to use as an optically active substances. So what is the advantage of this adsorbent is it can selectively adsorb one enantiomer by other and in preference to other. So if you are doing column chromatography, two enantiomer move in the column at a different rate and you can get it separated now. So a racemic mixture of camphor can result into its enantiomer using D-lactose as the adsorbent, that is D-lactose column. So these are the four methods. And next topic, what is mean by relative and absolute configuration and DL rotation. This D and L is capital L, which is different from the one small d dextro and levo L. And relative and absolute configuration, actual configuration, actual spatial arrangement of atoms or group in a molecule known as it is absolute configuration. But there was no method for determining absolute configuration. Hence, we want to understand the absolute configuration. Usually what we did is configuration is described with respect to glyceraldehyde. We arbitrarily chosen as a standard, and this was done by the scientist Rosanov, 1906. What he did is he did determine the configuration, absolute configuration with relative to glyceraldehyde. So all configuration described with respect to glyceraldehyde is known as relative configuration. For example, this is the structure of glyceraldehyde and this is capital D glyceraldehyde. This plus sign is this one is dextrorotatory, that you can get it from polarimeter. And this is capital L glyceraldehyde and this is levorotatory. And this plus glyceraldehyde, what he did is he put he selected this glyceraldehyde because most of the sugar molecules are derived from this structure, and this plus glyceraldehyde is having OH on the right and H on the left. At the same time, CHO at the top and CH2 at the bottom. And he has given for this structure the symbol D. And its mirror image he has given the configuration L. And any compound that prepared or converted into glyceraldehyde will belong to D series, or any compound that prepared or converted into L-glyceraldehyde will belong to L series. So OH on the left and with CH2OH, this structure will belong to L series, and OH on the right and H here, CH2OH will belong to D series. And conversion of glyceraldehyde to glyceric acid by oxidation gives the configuration D. You can see that this is D-glyceraldehyde. This on oxidation it gives another compound, glyceric acid, with this structure. So you can give the configuration D notation, capital D notation for this compound, even though this is a levorotatory, because this is does not have any bond break here. Okay, right. Similarly, lactic acid, that is D-glyceraldehyde, you can prepare lactic acid from D-glyceraldehyde, which is obtained like this. It undergoes oxidation and it form CHO, will be converted in first step to COOH, and this CH2OH converted into Br, then finally the Br is reduced to CH3 and you get a lactic acid. So this structure will be D-lactic acid because this is derived from D-glyceraldehyde. Similarly, you can determine the configuration of all other compounds. Similarly, L-lactic acid will be the hydroxyl group on the left. Okay, so you can decide D and L notation in every compound like this. So just understand that there is no correlation between DL and sign of rotation small d or L or plus or minus. This capital T and L is different from small d or L or plus or minus. Okay, in summary, the process in which one enantiomer dextro-levo of optical active compound is converted into racemic mixture is called racemisation. And the separation of racemic mixture in this T and L enantiomer is called resolution. And actual spatial arrangement of atoms or a group in a molecule is known as absolute configuration. And the whole configuration described with respect to glyceraldehyde is known as relative configuration. Okay, thank you for watching.